LALR is a parser. It's a one type of bottom-up parser. LALR is nothing but look-ahead LR parser. It overcomes the issues from the CLR parser by avoiding more computation and more memory usage. That can be achieved by merging of similar states. These are the steps to follow to solve the LALR parser. These steps are similar to CLR parser. Only thing, we should merge the similar state. In your examination, the question can be given like this. One grammar is given and one or more input strings are given. The first step is write an augmented grammar. Augmented grammar is nothing but adding the new production rule like this. So this is called augmented grammar, that is represented as G dash. So the first step is over. Then go to the second one. Finding LR of one items is nothing but adding the dot operator into the starting symbol in G dash. In G dash, this is the starting symbol. So I add the dot operator in this place. And I should add the necessary look ahead symbol here. Look ahead symbol is nothing but following element. So the capital S is the starting symbol. So the follow is by default dollar symbol. For this capital S, I write this production here with dot operator. This production can be formed from this capital S. So the follow of capital S is dollar. So I write dollar symbol here. In this production, after the dot, capital C is there. So I write these two productions here with dot symbol. These two productions are formed from this capital C. The follow element is another capital C. So I write the first of capital C as the look ahead symbol. First of capital C is small a and small d. So this is the LR of one items. So the second step is over. Now I am going to third step. Third step is nothing but apply the goto functions with all the symbols available in the grammar. You just follow these rules as we followed in simple LR as well as CLR. Check the particular symbol after the dot. If it is there, you can write it with the shifting of the dot operator and write the same look ahead symbol here. After the dot, there is no element, so you stop this process. For this capital C, after dot capital C is there, so I write these productions here. S tends to C dot C and write the same look ahead symbol here. After the dot capital C is there, so I write these two productions here and I need to find the new look ahead symbol. These productions can be formed from this capital C. So the follow of this capital C is dollar symbol. So I write dollar symbol here. These productions also can be formed from this capital C. The follow element is dollar symbol. So I write dollar symbol here. In this case, small a is there. So I write C tends to A dot C and write the same look ahead symbol here. After the dot, capital C is there. So I write these two symbols and find the new look ahead. This production symbol can be formed from this capital C. The follow elements are ARD. So I write ARD as the look ahead symbol. In this productions can be also formed from this capital C. The follow elements are ARD. So I write ARD here. In this case, I write C tends to D dot and write the previous look ahead here. So go to functions for I naught with all the symbols are over. This process can be continued in the resultant sets also. This is the end state. So if you apply go to functions for any symbols, it becomes nil. So I am going to the state number 2. In this case, there is no capital S after the dot symbol. So I apply capital C, A and D only. When I apply capital C, these rules become S tends to CC dot and add the dollar symbol. When I apply small a, these rules become C tends to A dot C and dollar symbol. After the dot, capital C is there. So I write C productions here and find the new look ahead. These two productions can be formed from this capital C. So the follow element is dollar. So I write dollar symbol as look ahead. These two productions are almost similar but only differ with the look ahead symbol. So I treat it as the new set called I6. When I apply small d, I can get C tends to D dot and dollar. These two productions are almost similar but only differed with this look ahead. So I named as I7. For this I3 set, when I apply capital C, I can get C tends to AC dot and look ahead symbols are ARD. This is the new set, so I named as I8. When I apply small a in I3 set, I can get C tends to A dot C and look ahead symbols are ARD. For this capital C, I write C productions here. The follow of capital C is ARD, so I write ARD here. These two productions are same, so I write the set number as I3. In this case, I can get C tends to D dot and look ahead symbols are ARD. These two sets are same, so I named as I4. From this resultant set, I5 is the closed state, so I am going to find the goto functions in I6 state. Here, when I apply capital C, I will get C tends to AC dot dollar. These two sets are similar but differed with the look ahead symbol. So I named as I9. When I apply small a with I6, I can get A dot C dollar. For this capital C, I write these two productions and the follow of the C is dollar symbol. So I write dollar symbol here. These two sets are similar, so I named as I6. When I apply small d in the set I6, I can get C tends to D dot dollar. These two sets are similar, so I give the set name as I7. So go to functions for I6 over. I7 is the end state, I8 is also end state, and I9 also end state. So go to functions over. Now I try to remove the same states present in this diagram. So this is the complete goto functions and the resulting states from the goto functions. So from these third steps are over. Next we are going to merge the similar states. So in this I3 and I6 are identified as similar states. It contains same productions but only differ from the look ahead symbol. So I merge I3 and I6 as I36 and I4 and I7 also similar state, only differ with the look ahead symbol. So I merge I4 and I7 as I47 and I8 and I9 also similar state. So I merge I8 and I9 as I89. Next step is constructing the parsing table. In constructing parsing table, first we identify how many states are available. Here there are maximum 9 states are available. So I write 0 to 9 rows and identify the terminals available. Here A and D are terminal and ended with dollar symbol. And I write the non-terminal available in this graph map. So this is the initial stage for constructing the CLR as well as LALR parsing table. Then I am going to fill the values as row wise. First I identify what are the states are non-ending state. Non-ending states are nothing but from this state after application of go to symbol we can get the new states. So I0, I2, I3, I6. Using these four values we are going to fill 0, 2, 3 and 6th row. First I take the I0 values. 0 versus capital S 1. 0 versus capital C 2. 0 versus small a 3. I write shift 3 here. 0 versus small d 4, shift 4. 0th row over. Then I am going to second row. In this second row, I2 capital S nothing. So don't fill anything in this column. I2 capital C 5. I2 small a shift 6. I2 small d shift 7. Second row is over. Then I am going to fill third row. 3 comma capital S nothing. 3 comma capital C 8. 3 comma small a shift 3. 3 comma small d shift 4. Third row is over. Then go to the sixth row. In this sixth row, 6 comma capital S is nothing. 6 comma capital C is 9. 6 comma small a is shift 6. 6 comma small d is shift 7. So all the non-ending states can be helped to fill these four rows. Then find the what are the states are ending state. Here the ending states are I1, I4, I5, I7, I8 and I9. So these 6 states are helped to fill these rows. For the explanation purpose I write like this. In your examination you can directly write the values. For the first row capital S is going to end. So I write accept in the dollar column. So 1 and dollar always accept for all the grammars. In the fourth row, third rule is going to end. So you should write R3 in the column A and D. In the fifth row, first rule is going to end. So you should write R1 in dollar column. In seventh row, third rule is going to end. So you should write R3 in dollar column. In eighth row, second rule is going to end. So you should write R2 in A and D column. In ninth row, second rule is going to end. So you should write R2 in dollar column. So this is the parsing table construction method followed in CLR parser. We already conclude what are the similar states are available and how to merge these states. First I take 3 and 6. From these two rows, if I merge these values, S3 becomes S36, S4 becomes S47, this 8 becomes 89. And this 6 also can be merged with this row. In this table, S3 and S6 also there, so it also changed into S36. Now I remove this unwanted row. So merging the first part is over. Now I am going to 4 and 7th row. When I merge these two values, R3 can be located in this place and 7 can be merged with 4. So wherever the values 4 and 7, it also becomes S47. Now I remove this unwanted row. Merging the second part is over. Now I am going to the 8th and 9th row. When I merge these two, R2 can be located into here and 9 can be merged with 8 as 8 9 and change if there is any single 8 or 9 values. 8 9 is already merged here, so no need to do this, and remove this unwanted row. So this is the complete merged table. So this table is now called LALR parsing table. So from these steps up to 5 steps are over. Now we can do the stack implementation process for the given input string. First I take the input string AAD. I will do this process with the help of LALR parsing table. First I compare 0 and A here. The value is shift 36. Shift 36 is nothing but shifting the A value here along with 36. 36 is the single element, so I represented as in a yellow color. Then compare 36 versus A. 36 versus A, again shift 36. Shift 36 is nothing but shifting the A element along with 36. Now compare 36 versus small d. 36 versus small d is shift 47. Shift 47 is nothing but shifting this d value here along with 47. Now compare 47 and dollar. 47 and dollar is reduce 3. Write the third rule here. This rule contains single element, so you remove the two elements from the list. Remember that 47 is the single unit and the d is the second one. So remove these two elements and replace the capital C here. Compare 36 versus C. 36 versus capital C is 89. So write 89 here. Compare 89 versus dollar. 89 versus dollar is reduce 2. Reduce 2 is rule number 2. Here two elements are there. So you should remove 4 elements from this stack. 89 is the first element, C is the second element, 36 is the third element, A is the fourth element. Or you can remove the elements up to small a from the stack. So remove these elements instead of capital C. Compare 36 and capital C. 36 and capital C is 89. Compare 89 and dollar. 89 and dollar, again reduce 2. Reduce 2 means you can remove the 4 elements instead of capital C. Compare 0 and C. 0 and C is 2. Write 2 here. 2 and dollar. In 2 and dollar, there is no element in this parsing table. So you write error message. So the given input string is invalid for this grammar. The next input symbol is DD. Compare 0D in this parsing table. 0D is shift 47. Shift 47 is nothing but shifting this D along with 47. Compare 47 with small d. 47 with small d is reduce 3. In the third rule, only one element is there, so I remove these two elements. Remember, 47 is the single unit. So instead of these two elements, I write capital C here. 0C, 0 capital C is value is 2, so I write 2 here. 2 and small d, 2 and small d is shift 47. Shift 47 is nothing but shifting d here along with 47. 47 and dollar. 47 and dollar is reduce 3. Identify two elements and remove with capital C. Compare 2 and C. 2 and C is 5, so I write 5 here. Compare 5 and dollar. 5 and dollar is reduce 1, write the rule number 1. Rule number 1 has two values, so I remove 4 values here. So instead of these 4 elements, I write capital S, 0 and S. 0 and capital S value is 1, so I write 1. 1 and dollar, 1 and dollar is always accept, so I write accept as the action value. So DD is the input string, is valid for this given grammar. So in this way, you solve the LALR parser problem in your examination using these steps. Make a comment for any queries.